previous session we have seen the design procedure for knuckle joint and systematically we have designed that. Now it's time to solve the numerical for the design of a knuckle joint. I'll read the numerical and try to solve in front of you sequentially. That is very important. So see, I'll read the numerical. It is required to design knuckle joint, very important, knuckle joint having tensile force of 50 kilonewton. So I'll write given data P is equal to 50 kilonewton 10 raised to 3. Having yield strength SYT, yield strength in tensure 400 Newton per mm square and its factor of safety 5. Design a joint, okay, and specify its dimension. So I need to draw the diagram also. So here the indication is this. Now we'll start with the step number 1. Step number 1 is permissible stresses, calculation for permissible stresses. Now we have seen from the statement the material for the each part is given same as well as a factor of safety also same. So there is no need to add the multiple stresses. So we'll have to take the basic consideration of the stresses. First one is tensile stress, that is SYT by factor of safety. SYT is 400 divided by factor of safety is 5. Therefore our tensile stress is 80 Newton per mm square. Correct? Then we'll move toward the crushing failure or crushing stress. In case of the crushing stress, they have not mentioned the yield strength in compression, that is SYC by factor of safety. So I will have to take same as that of given, that is no condition is given, therefore it is again 80 Newton per mm square. Clear? Now shear failure is occur, that is 0.5 of SYT by factor of safety. So I can multiply by 0.5 into 400 divided by 5. So it is half of that, it is 40 Newton per mm square. Clear? So this is about the permissible stresses. Step number 1 is for the designing of given statement. Now we'll move toward the step number 2, that is calculation of diameter of rod. So diameter of rod is capital D. Correct? So capital D, for that we have seen, that is tensile stresses occur P by area pi by 4 D square. Therefore D is equal to 4P by pi into sigma T under root of this. So this will be the consideration for the design, and through which I'll write diameter, sorry, this is not, this is capital D. So therefore capital D is equal to square root of 4, P is 50 into 10 raised to 3 divided by pi, sigma T is 80. So diameter of rod, it is in mm. So I'll get the diameter of rod, it is in mm, it is 28.2. You can calculate, and it is nearly equal to 30 mm. So I will have to consider diameter of rod is 30 mm. So this was the step number 2. We'll move toward step number 3. Step number 3, which is related with the empirical relations. Empirical relations. Now in case of the empirical relation, we'll have to consider one by one. That is, enlarged diameter D1 is equal to 1.1 times D. So I'll multiply 30 into 1.1. It will gives me around 35 mm. Then I will have to consider the value of A 0.75% of D. So by multiplying D is nothing but 30 mm, I'll get A is equal to around 25 mm. And then B is equal to around 1.25 times D. Correct? So by multiplying this, I'll get around 40 mm. So these values are round figure I have taken. See, after B is equal to, you will get 38 point something answer. So that I have converted into 40, same as 25 and same as for 35. So these are the empirical relation. In addition to that, we have seen that DO is equal to twice of D. So directly multiply 60 mm. And in case of the D1, that is diameter of pin head. Diameter of pin head, that is 1.5 times D. So it is around 45 mm. So these are the empirical relation which we have seen as per the sequence that we have used. So this is about the step number 3. Now we'll move toward the step number 4. Step number 4. In case of the step number 4, we'll have to design diameter of pin. Is that correct? Design diameter of pin, notation small d. So for the diameter of the pin, we have seen the two equation as per the shear failure. As per the shear failure, I'll write diameter of pin D directly, or instead of that, for your understanding, P by pi by 4 D square. It is about double shear, multiply by 2. Therefore D is equal to, you will have to get square root of 2p by pi into tau. So here I'll put 1 by 1, that is 2 into 50 into 10 raised to 3 divided by pi. And shear stress for what? Shear stress for pin. How much? 40. So 40. So through which I'll get the diameter, which is in mm, is around, try to calculate from your end, it is around, that is 28.2. So it is nearly equal to 30 mm. This is from the shear failure. Now from bending failure. From bending, we have seen, I'll directly write the equation because we have seen the derivation for it. So D is equal to cube root of 32 by pi into sigma b into p by 2 in bracket 1/4 of b plus 1/3 of e. Correct? So A and B we have calculated over here. P is known, sigma b, instead of this sigma b we have not calculated anywhere, so we'll have to take tensile stress. Remember this, we did same thing in quarter joint also for quarter strip, correct? So tensile is 80, so I will have to calculate a diameter is equal to, it is cube root of 32 by pi into how much, 80 into P, 50 into 10 raised to 3 divided by 2 in bracket, B is how much, 40 by 4 plus A is how much, 25 by 3. Correct? So through which also diameter, so diameter is in mm, so just try to calculate, and diameter is around 38 point something, and which is 40 mm. So these are the two diameters which we can get, once from this shear and another from bending. So select maximum. Correct? So maximum is D is equal to 40 mm. Need to select. Correct? Select maximum. So this is about the diameter of the pin. Now we'll move toward the step number 5, is totally related with design of eye. Design of eye. For that we have seen the checking of stresses we are going to do here. Checking of stresses. Now while doing the checking of stresses, I will have to use one by one, that is first of all tensile is nothing but P by area, B into dO minus D. So just I will have to put the value. P is nothing but 50 into 10 raised to 3 divided by B is how much? 40 into dO is how much? 60 minus D is 45. So by putting this, I will have to get the stress value sigma T for the case of I is 31.25 Newton per mm square. Correct? Which is always less than 80 Newton per mm square. Why 80? See, permissible, first step 80 we have calculated. So calculated value is less than permissible, then design is safe. I told you. Design is safe for tensile. So same we'll have to use for the crushing. So I'll write crushing failure is equal to P by B into D, which is again P is 50 into 10 raised to 3 divided by B is nothing but 40 and D is nothing but 40 diameter we have selected, and therefore the crushing failure value is 31.25 Newton per mm square. It is again less than 80 Newton per mm square. So design is safe for crushing. Correct? In that the part is remaining is shear failure. Shear is nothing but P by B into dO minus D. So same I will have to get 31.25, which is again less than 80. So design is safe for shear failure also. So this is for the I section design, and that is okay, that is safe as per the calculated value. As like here we have calculated this much, which is less than 80 because related to the 80, and see here not 80, here is 40. Correct? Because shear failure it is having 40 value. So I will have to write here is 40, and of course the 31 point something is less than 40. Therefore design is safe for shear failure. Then step number 6. Step number 6. Checking for fork. So crushing, shear and tensile for fork. So I will have to write tensile failure, that is P by 2A instead of B. I will have to write 2A dO minus D. So through which I can say how much it is, 50 into 10 raised to 3 divided by 2 into A, 25 into dO, 60 minus 45. It will gives me again 31.25 Newton per mm square. So this value 31.25 is less than tensile is 80. So design is safe. Design is safe. Correct? Now we'll move toward the crushing. Sigma C is equal to P by 2A instead of B. I will have to 2A into D. So by putting the value 50 into 10 raised to 3 divided by 2 into A is 25 into D is 40, will gives me the crushing stress value gives me the crushing stress value is 40, sorry, will give the crushing stress value is 25 Newton per mm square. I can compare this, crushing is 80, design is safe. And lastly, in case of the shear failure, I will have to write P by 2A, same equation as that of tensile. Therefore, it is also around 31.25, which is less than shear failure 40 Newton per mm square. So design is safe. Design is safe. So likewise we'll have to use the procedure for solving the numerical, and very simple procedure. What we did, We did the permissible stress, that was the first step. Second is the empirical relation, that was second. Third one is we'll have to calculate the diameter of pin. Fourth one, design of the checking of the eye section, checking of the fork section, and if it is fail or safe, we'll have to check, and then we'll put the remark. So this kind of the numerical will be asked in exam, and you will have to follow the same sequence so that you will get good marks and you will not get confused for the empirical relation and all that. Please maintain this sequence and try to solve number of numericals from your end. Thank you.